Today we will discuss about a topic related to electrostatics. We will find out electric field due to a uniformly charged circular loop at a point on its axis. This is the thing we will deduce today. So to do that, first let's draw the diagram.
Baba.
So let's say we have a circular loop like this, and we need to find out the electric field at a point on the axis of it, like this. So to do that, let us first consider that the radius of the circular loop be r. So let this radius be r. So let this is r, and the point at which we are actually trying to find out the electric field, let its distance from the center be x. So let this distance be x, the point at which we need to find out the electric field. Let that be the point, that is x. Now to find out this, as it is a uniformly charged circular loop, we are considering few things. We are considering lambda as the charge per unit length, and capital Q as the total charge of the loop. Now let us consider a very small elemental length of dl at this point of the, or at this position of the circular loop. So if we want to find out the electric field due to this small elemental length, let this will act, or this field will act in this direction like this, and the distance that it will have from the point, it will be this. As you can see, it will be root over of, by Pythagoras theorem, it will be root over of x square plus r square. Now if we consider another elemental length just opposite to this elemental length, here, somewhere here at the bottom, here, here, like this. Again, for this elemental length, the electric field will act on the point P in this direction with the same distance between the 2 points. So it will be like this, as you can see. So both these electric fields, first one is acting in this direction, second one is acting in this direction. They are having the same magnitude, but their directions are different. And if we actually divide this electric field in two components, one parallel to the axis like this, let's say if we want to divide this electric fields, one perpendicular, straight line it will be, so one perpendicular to the perpendicular to the axis, and it is in this direction, and one parallel to the axis, which will be in this direction at this point. It will actually act like this. Similarly, for the other electric field, it will be same, and again one of the components will act downwards like this from here, and the other one will again act along the axis, and I am just putting the direction of it like this. So as you can see, these two components, these two means this component and this component, they are having the equal magnitude but acting in opposite directions. So they will actually cancel out. So if we actually name this angle to be theta, that is the angle made by the line with the axis as theta, then only the cos theta component of the electric field, because if these angles are theta, this will also be same theta, this angle will also be same theta, only the cos theta component will remain, sin theta component will cancel out. So the electric field, if I write for this elemental length dl, electric field and let the point, I have not named it, let the point where we are actually having the point, let the point be P. Electric field at P due to dl if that is d e p, then we can write this DEP as, I'm writing it again, DEP will be equal to the electric field, that is lambda dl is the charge in the elemental length dl, divided by 4 pi epsilon naught square of the distance. Distance is, we have already seen, is x square root over of x square plus r square. So it will be x square plus r square whole square multiplied by cos theta. Now what is cos theta? So cos theta in terms of x and r we need to write. So this will give us, this will be equal to this will be equal to, if I write the value of cos theta in terms of x and r, it will be lambda dl by 4 pi epsilon naught x square plus r square whole square multiplied by cos theta, as you can see from the diagram here, as you can see from the diagram, cos theta will be r by, sorry, x by root over of x square plus r square. So cos theta will be here, if I write, it will be x divided by root over of x square plus r square. I'm writing it, it is a bit clumsy, so I'm writing it again. X divided by x square plus r square to the power half, or rather root over of this, same thing. So this will give us DEP as lambda as lambda x dl divided by 4 pi epsilon naught x square plus r square whole to the power 3 by 2. So this will be the electric field due to the elemental length dl. Now if we go back to the diagram again, you see, if we consider this elemental length dl anywhere, let's say here we are considering, so for this elemental length dl, there will be another elemental length opposite to it, and for the same reason that we had in the previous case, only the component along the axis of the circular loop will exist. The components which will be perpendicular to the axis, they will always cancel out because of the symmetry. So wherever you will actually consider the elemental length, if we consider here, again there will be an elemental length just opposite to it, and for those two elemental lengths, only the component which is along the axis of the circular loop, it will only remain. The other component which will be perpendicular to the axis, they will always cancel out. So actually, the total electric field, if now we want to have the total electric field, it will be equal to, so EP, that is the total electric field at P, will be integration dEP, and as you can see, only in this case, for a specific point and for a specific loop of radius, of some radius, only dl is the variable. So all the other things are constant. So integration will only happen of dl, and all the other terms will be constant. That is the distance from the center, the radius of the loop, all these things will be constant, and it will actually be only integration dl multiplied by all the constants. Now integration dl will only give us what? It will only give us the circumference of the circular loop, because if we go on adding all those dls, we will only get the circumference. So it will only give us lambda x by 4 pi epsilon naught x square plus r square whole to the power 3 by 2 multiplied by 2 pi r. Now lambda multiplied by 2 pi r, so this will give us actually what? Lambda 2 pi, let me do it again. So this will give us lambda, or 2 pi lambda r multiplied by x divided by 4 pi epsilon naught x square plus r square whole to the power 3 by 2. Now 2 pi r lambda, as lambda is the charge per unit length, this whole term will give us the total charge q of the loop. So it will be actually qx by 4 pi by 4 pi epsilon naught x square plus r square whole to the power 3 by 2. This is the required expression for the electric field. I hope you have understood. Thank you. So, if I may say that if I just have it within a box, this is the required or the desired relation that you want to have. This qx by 4 pi epsilon naught x square plus r square whole to the power 3 by 2. Okay, thank you.